I'm Mindy Mendkya, and today I will be talking about moisture content and water activity in cannabis plants. Cannabis plants behave differently based on different levels of water intake. Wet and dry climates do play a role in this. So performing moisture analysis is highly important because you want to keep the consumer safe. Education about testing for moisture content is important for anyone who is in the cannabis industry or anyone who's looking to get into it. There are two important terms that it is important to distinguish between, and that is water content and water activity. Water content refers to how much water is contained within a substance, and this scale ranges from 0% to 100%. And water activity does refer to how tightly bound the water molecules are to the structure that it is in. This scale ranges from 0 to 1, with 0 being nowhere close to being water and 1 being pure water. I went about this research by using three main search engines. I used PubMed, Core, and Google Scholar. I used key terms like moisture analysis tests, water activity in cannabis, water content in cannabis, and water in cannabis. And I had found different peer-reviewed literatures, which I had refined down into one document. So I did come across three main types of testing for moisture analysis. That was a moisture balance, drying oven, and a moisture meter. Each of them are very simple to use. And Shamadsdu, they had done an experiment using their own instrument. It was a moisture balance that had a compartment above it that was used to dry out the sample. So they had run trials at three different temperatures. Each they ran samples at each temperature in triplicate. The three temperatures that they had set their instrument at was 105 degrees Celsius, 110, and 120 degrees Celsius. And each duration went for 15 minutes. And then it was concluded that the samples ran at 120 degrees Celsius did have the biggest amount of water loss. And that is expected because at higher temperatures, you're going to have a higher rate of evaporation. So during different stages of production, there are different required standards. Your initial drying, you're going to want to have a water content percentage of 14 to 15%. After it's cured or prepped for storage, you're going to want to look at an 11 to 12% water content. However, if you are going to be making a vape product, you are going to want to make sure that those are cured from 12 to 15%. Now, based on what you're looking to get from the product, if you're looking to get a pleasant smoke, you're going to want 10 to 12% water content. For a harsh dry smoke, you're going to want 10% or less. And if it's going to be a medicinal product, you're going to want to look at having your cannabis 6 to 9% water content. And that is because you want to be able to prolong those shelf life along with having an increased potency. So environmental strain does play a big role. Overwatering the plants will end up drowning out the plant, and underwatering or those dry environments will result in wilting or poor growth of the plant, especially over time. Humidity is important because it helps balance evaporation in the plant, and lower humidity levels do result in more nutrients and water absorbed by the plant. Many industries do use moisture analysis. Dentistry, they use it to test the brittleness of teeth. GIS uses it to determine soil moisture, and pharmaceuticals use it to test the moisture content in their medications. Medicinal cannabis does undergo gamma irradiation, which is to ensure that there are no microorganisms that could be present due to excess moisture. This process involves cobalt 60, which decays and then produces the gamma rays, which are used to kill off those microorganisms. There actually was an attempt to see if industrial hemp could be used to replace different high moisture meat analogs in food. A twin screw co-rotating extruder was used to break down the hemp, and then water percentage was found to have an effect on the texture of food. The higher water percentages in the cannabis plants resulted in a less chewy and more tender product. The method of moisture analysis is more dependent on the sample sizes you'd be working with. Commercially, a drying oven would be more beneficial, whereas if it's just more on a small scale for personal use, you're going to want to look into a moisture meter or potentially a moisture balance, but a moisture meter may be the most beneficial. All of this contributes to the one main end goal, and that is to keep the consumer safe. And that concludes my presentation. I would like to acknowledge and thank my mentor, Professor Southwell, and my instructor, Dr. Wynn, for providing feedback on my research over the duration of this semester. Thank you.